We will now begin our questions section. So anyone can line up at the two microphones, and I would invite the speakers to come up to answer questions as well. Thank you.
Go right ahead.
Are you ready?
I think so.
You sure?
Well,
Okay.
who's your question for?
Oh, well, it's actually to everybody.
Okay.
Because I've been sitting here listening to things that I don't really understand. But the gravity data that we got from Grail on the moon has been used to track some voids in the subsurface related to these pits to show that there are potentially extensive lava tubes. But I didn't see any link between what you were doing and what that work that has been done on the moon. And gravity was used in the last talk. And I would like to get comment on, doing these analog studies down here and equating that to what we know on the moon from the geophysics, and using those data sets and those techniques down here to actually then do it on the surface of the moon would be really useful. So is that being thought about? Is that being done, and that sort of crossover?
I think Jacob has an answer for you.
Yeah, Clive, I think that's a great question. I have some opinions about it. I'm not sure if you saw Katie Gansler's poster yesterday, but one of the problems with potential fields that other measurements don't necessarily have a problem with is potential fields spread out dramatically from orbit. And I think that lava tube detections with even the best Grail data is not necessarily reliable. It's certainly not possible for lava tubes at the scale that we have on Earth. Maybe those small lava tubes weren't able to be preserved over billions of years, and so maybe the bias that we see in the gravity is complementary to the preservation bias of large tubes. But from orbit, we would only be able to see the largest tubes with gravity, and it would be impossible to see these with magnetic data just because of the lack of a field today.
Right, but the point being is, if you're developing field techniques to detect them here, show the applicability, we need to get that to the moon to map these out on the surface. I was just trying to see the connection there.
Yeah, I agree. Geophysics works best from the ground. So the more we can get
it depends who you talk to. So.
Maybe what we would need, I guess, Clive, is like a network of geophysics.
Oh, yeah. Wouldn't that be good? If only we could get a proposal into New Frontiers to do that. Yeah.
I just really quickly wanted to add to that, because I am Katie Gansler and had that poster. One of the things that we're also working on, I'm building on Kevin Lewis's work from 2019 using the Curiosity Inertial Measurement Unit, which is their accelerometer, as a gravimeter. It's obviously not going to be as high of a resolution for, at least from the gravity measurements, as say Grail, but its horizontal resolution will be better. And I believe Viper is actually going to be, measurements from Viper's IMU will also be used as gravimetry. So testing the feasibility of basically having a little car to do that ground mapping is in the works.
I'm just going to add on and say this is part of the reason why observations like Edward's observation of the fractures on the other side, or Danielle's pit chains over voids, when we have those surface features that represent a subsurface void, those can help us where the resolution of data, like the gravity data, isn't sufficient right now. Before I go to you, do we have any questions online? Okay, Patrick.
Thank you. My question's for Ben. I'm curious if you've thought about, so you had the kitchen sink of geophysics methods to do the modeling. I'm curious if you've done sensitivity work, or just have thoughts about which methods could you leave out and still get a reliable answer, or even the other way around. What is the minimum set of methods that you could of data that you could use to get a reliable answer from your model?
Okay, so the beauty of the methodology is that the sensitivity matrices, these sensitivity kernels, if you will, can be sort of plugged and unplugged at will. And you can use essentially any measurable you want, as long as you can forward model it in a reliable way. So my approach is everything in the kitchen sink. I'm going to take every geophysical data set I can possibly get my hands on, use that. The results are almost always better in the face of more information versus less, but still leave my version of the code structured in such a way so that we can use whatever we have and not necessarily have to rely on everything all at once. But I'm looking at electrical resistivity, seismic reflection and refraction studies, just to name 3 off the top of my head.
Thanks.
Anything online?
David Hollaba Baker, NASA Goddard. This question for Jacob. So just thinking about the skylights and the ages of the rocks that you might measure, and the ability to kind of, capture the changes in the dynamo. I would think the ages might be over a restricted range. So can you, or maybe a larger range? I guess, what are your thoughts on if you went to the moon, to a skylight, kind of what ages of rocks and your ability to resolve those changes in the dynamo?
Yeah, that's a great question. I'm certainly not a geochronologist, but I think that wherever we land on the moon, we face that problem, right? So by going to a place with the strata, I think if a careful selector of a pit to do a survey like this would choose either a stack of lava flows that's just lava flow after lava flow, and then you get to see a sort of potentially a shorter timeline of what the magnetic field on the moon is doing. Or you could select a pit that has slope forming units that might actually be regolith development, so you get a longer version of time. And I would leave that up to the mission question that you're trying to ask. But yeah, that's a fantastic question, because we aren't going to know how old these things are until we go there, right? You can't do crater counting on a wall, I think. Can you?
Yeah, just interesting to think about. Yeah, thank you.
Yeah, that's a fantastic question.
I actually have a question for Edward. I'm a big believer in looking at surface features that give you hints as to what's going on in the subsurface. So the fractures that you were observing at lava tubes, have you had a chance to do any kind of systematic search for those on the moon, like on either side of rails? You showed an example, but how extensive has your identification of those kinds of features been?
Yeah, it's a good question. Thanks. Yeah, I have been looking around a lot of known rills on the moon to try and find if I could see any more examples of cracking like that. I haven't made like a comprehensive atlas, but I've just been looking at notable rills where I thought there might be some and looking for any signs of cracking. In the vast majority of cases, I didn't see anything, but there was, I think, part of Rima Sharp, I think I saw what looks to me like the linear cracking next to the tube. And also next to, there's a discontinuity in Rima Marius where there's not directly cracking, but there are lines of depressions next to it that I think could be regolith draining into the cracks. So I've looked around a lot and I found a couple more examples.
Anyone else? Jacob is heading to the microphone.
Yeah,
So
Jacob Richardson, NASA Goddard Space Flight Center. I have a question for a few people, but especially Naoma and Lyndon. I'm wondering, can you put a floor on the size of a lava tube for seismic methods or any of these other methods? Maybe for Ben, is there a small feature in the subsurface, whether it's a lava tube or some other contrast feature, that smaller than this, don't use our instrument, larger than this, definitely use our instrument?
That's a very good question, and I think it ties into a little bit of what I talked about in my presentation, where the 2.3 meter diameter tube was much harder to detect, especially at very shallow surface. But this also ties into what we can realistically expect our station, receiver, and source geometry to be. because we want finer sampled stations and sources to notice smaller tubes, such as 0.5 meter source and receiver spacing that Naoma talked about a lot for Skull Cave. However, this is less applicable and feasible really to do on the moon. We wouldn't really be able to have such fine spacing for current methods that we would expect to use. A floor on Hall smell that would be, I suppose I could also tie into why do you want to detect tubes that are that small? The lower constraint on mine was kind of modeled around the person is about 1.5 meters. So we want sort of 2 meters and above tubes to find on the moon for them to get into and be able to use. Obviously, smaller tubes would be less usable for shelter, other reasons on the moon. And we don't really expect lava tubes that small on the moon. But it is very dependent on station and receiver spacing, and finer spacing will see smaller objects, whereas we can sort of throw out such fine spacing if we say, okay, we have a tube this size, we want to find it, let's find the smallest spacing we need, but not oversample and overextend the people collecting the data.
I think Lyndon covered most of it, but another thought I had was that it's probably highly dependent on what source we're using and our spacing and everything. Like thinking about the data that I've seen that I processed, like we didn't see a lot of reflectors below 50 meters. And so some of those tubes are deeper than 50 meters. So I think we need to think about our survey parameters and source we use in terms of how deep we want to resolve some of those structures. Also, while I'm up here, I just want to say that I'm slightly horrified that in my haste, I skipped my acknowledgement slide. And so I want to be sure to acknowledge the Survey Geodes project that enabled this research, as well as the GIFT Lanzarote project that allowed us to tag on and handle a lot of the logistics, as well as the Cruise MATLAB project and ESA, Vigia, and Tomasi and co-authors that allowed us to use their LiDAR. So thanks.
It is 10:30, so the virtual poster session is starting, and they would like us all to try and attend that. Katie, did you have a quick question or?
Nah, but I work with you guys, so I can just ask later.
So why don't we all go to that virtual poster session and see all of the wonderful online presentations, and see you in the afternoon for the talks. Thank you.